Hello, everyone. Welcome to First Online University, a global platform for all your education and growth related needs. In this lecture, we are going to start a new chapter that is nitrogen containing compounds. Now, when I say containing compounds or nitrogen containing compounds, it simply means that we are going to discuss those compounds that have functional groups that contain nitrogen. And in this particular lecture, which will be not just an introductory lecture, but it will also include certain important concepts, namely the structure of such compounds, their classification, and nomenclature of amines particularly. So here we are going to talk about amines in particular, and we will be discussing a lot more nitrogen containing compounds in the upcoming lectures. Before we begin, a piece of information for you. You can use the coupon codes Mission JEE or Mission NEET while you enroll at First Online University for Mission JEE or NEET. So in this particular chapter, we are going to cover amines, diazonium salts, cyanides and isocyanides, that is 4 different nitrogen containing compounds. And in this particular lecture, we will be discussing amines in detail. So let us first start with the structure of amines. Now, those organic compounds that contain nitrogen are either amines, diazonium salts, alkyl cyanides, or alkyl isocyanides. When I talk about amines are definitely, this is something which is a very simple nitrogen containing compound. And this is something that everybody is aware of. So when we say amines are basically the derivatives of ammonia. Ammonia is NH3. So when I say derivatives of ammonia, it means we will have NH2 functional group, which is going to be present in any organic compound. And we call that organic compound as amine. So this is obtained by replacement. So what happens is when, one, two, or all the 3 hydrogens of ammonia molecule are replaced by some other alkyl or aryl group, we call it as amine. All right. For example, if I take the example of this particular compound where one of the, not one, not two, all the 3 of the hydrogens of ammonia molecule, that is NH3, have been replaced by methyl groups. And there can be another example where we can have just the replacement of just one of it or 2 of it. Now, when I talk about the structure of amines, the nitrogen particular that the central atom is nitrogen, which is attached to other groups that would either be hydrogen or some alkyl or aryl groups. Now here, the nitrogen atom, just in the case of ammonia, just as in case of ammonia, has all the sp3 hybridized orbitals. And since there is, so the geometry is tetrahedral, but since there is a lone pair that is present on the nitrogen atom, the geometry is going to be pyramidal. Sorry, the shape is going to be pyramidal with the geometry being tetrahedral. Now, each of these 3 sp3 hybridized orbitals of nitrogen are going to overlap with each one of the orbital of hydrogen or carbon, depending upon whatever groups are attached to the nitrogen. And the 4th orbital, as I've already told you, contains a lone pair or unshared pair of electrons. So here we can look at the structure in detail, where we see that in the center we have the nitrogen atom, which is sp3 hybridized, where out of the 4, 3 sp3 hybridized orbitals are going to overlap with the orbital of carbon, and one of them will have unshared electron pair. The bond angle is 108 degrees instead of 109.5 degrees. Since there is one lone pair present, the bond angle gets reduced by 1.5 degrees approximately, giving the bond angle to be 108 degrees in this particular case. So based on the structure of amines, let us have a look at few concept check questions. The first one is, amines are derivatives of, very simple, ammonia, oxygen, water, or hydrogen sulfide. So we know amines NH2 are derivatives of ammonia NH3. So option A is the right answer. Next question is, in amines, the nitrogen atom undergoes which hybridization? Again, this is very simple. We know that nitrogen atom has sp3 hybridization. So option A is the right answer again. The third question, the number of lone pairs that are present on nitrogen atom in case of amine will be equal to the number of lone pairs that are present on nitrogen atom in case of ammonia molecule. And therefore, we know that there is just one lone pair that is present. So option C is the right answer here. Next, we move on to the classification and nomenclature of amines. Now, let us first classify amines into various types. Now, if you remember when we had talked about the alcohols in case of when we were discussing the alcohols, phenols and ethers, we discussed in detail about primary, secondary and tertiary alcohols, and we classified them into primary, secondary or tertiary depending upon the number of hydrogen atoms that were attached to the carbon atom that contained the OH group. So if there were two hydrogen atoms and one was the alkyl group, we called it as a primary amine. If there were two alkyl or aryl groups, we called it as secondary amine and secondary alcohol. And if there were all the three of them were R groups, where R could be any alkyl or aryl group, we called it as tertiary alcohol. Similar is the case with amines. But here, on the basis of the number of alkyl groups that are attached to the nitrogen, okay, here we are not going to talk about the carbon to which nitrogen is attached, but we are going to talk about the nitrogen itself. So if we have one alkyl or aryl group present, that is one R group present, it is primary amine. Two R groups present, it is 2 degree or secondary amine. Three R groups present, it is 3 degree or tertiary amine. Now, primary amine RNH2, secondary amine R2NH, and tertiary amine R3N. Now, in common system, an aliphatic amine is going to be named by prefixing the alkyl group to it. In secondary and tertiary amines, when two or more groups are present, when they are the same, we use the prefix di, tri, depending upon how many groups are present in the same quantity before the name of the alkyl group. And in the IUPAC system, amines are named as alkanamine, okay, like methanamine, ethanamine, like that, which is derived by replacing the E of alkane with amine. Okay, right now it might not be very clear to you, but as we move on and discuss the examples, you will be able to understand the rules of the nomenclature in a much better sense. So how are we actually naming it? Is alk, ane, E removed with amine or replaced with amine. So alkanamine. If different alkyl groups are present or attached to the nitrogen atom, the longest chain becomes the parent alkyl, and the remaining alkyl groups are going to be treated as prefixes, that too in the alphabetical order. So let us look at the since we have discussed the rules of nomenclature already, let us look into the naming of certain compounds. With examples, you will be able to grasp the rules of nomenclature in a much better way, and whatever points we have just discussed in the previous 2-3 slides will now start making sense to you. Now, if we have this particular compound that is given to us, that is CH3, CH2, NH2, what do we see here is that there are two carbon atoms. So obviously it is going to take its root name from alkane, that is ethane. And since E is going to be replaced by amine, the IUPAC name of it will be ethanamine. And we will also be discussing the common name, which is ethylamine, right? I hope this is clear. Now from the next slide onwards, the moment you get a compound in front of you, I would suggest you to pause the video there. Try to name the compound, just the IUPAC name, although common names are equally important, but sometimes you will not be able to predict the common name very easily because of the complex structure that is involved. But otherwise, you should be, for easy compounds at least, you should be able to answer the common name as well. So now what I suggest you is before I give you the answer for the IUPAC name and the common name, you should be ready with your own answers to whatever compound is shown to you on screen. And then you can match with it and you will gain confidence and also get a lot of practice in this process. So the next compound is CH3, CH2, CH2, NH2. Again, the root name is going to come from the alkane series, and since there are 3 carbon atoms, so it's going to be propane, with E being replaced by amine. So propanamine is going to be the IUPAC name, and propylamine, N-propylamine is the common name of it. Again, in case of propanamine, since there is a possibility that NH2 group can be present at the first or the second position, therefore it is important that we specify at which position do we have the NH2 group present. Therefore, you will not just call it as propanamine, but you will call it as propane 1-amine. Because now the next example is propane 2-amine, that is isopropylamine. These common names are very, very important. I'm again repeating. If you're not able to predict the common name, that's okay. But before you move on to the next slide, the common name should get into your brain. Okay? Because sometimes in the question, you will not be given, say, propane 2-amine reacts with this to give this. No. You will be given isopropylamine reacts with this to give this, predict the product. So when you do not know what isopropylamine itself means, you will not be able to proceed with the reaction and predict the products that are going to be formed. Therefore, it is important, very, very important, that you are well aware of the common names too. The next compound is CH3NH CH3. Now here it's a secondary amine that is given to you. So the common name is ethyl methylamine. See, what you have to do in such case is you have to look at all the alkyl groups that are present around nitrogen. So what do we see is on one side we have a methyl group, on the other side we have an ethyl group, and obviously going in the alphabetical order we will have ethyl and then methyl. So ethyl methylamine is going to be the common name. When move on to the IUPAC name of it, as we had discussed in the rules, the longer carbon atom containing chain, or simply the longer chain, will be treated as the parent chain, and whatever the other substituent is present, or whatever the other group is present, will be treated as a substituent attached to nitrogen. Since it is attached to nitrogen, we call it as N-methyl, and whatever is the longer carbon chain is going to be treated as the parent chain, and which is ethane here. So ethanamine. So N-methyl ethanamine. Okay, methyl being treated as a substituent attached to nitrogen, therefore N-methyl. And the rest is the parent chain including the nitrogen atom. So ethanamine. Right? I hope this is clear. So try this one by yourself. So here, this is a tertiary amine. The common name is trimethylamine, which is again very easy to predict. Okay, the IUPAC name of it will be NN-dimethyl methanamine. Even if all of them are equal, all of them are same or equivalent, one of them has to be definitely treated as the parent chain, right? So we say that I treat one of the CH3 groups as the parent chain, so methanamine remains there. Now there are 2 other methyl groups that are left, which are going to be treated as substituents and named in the, or be written in the IUPAC name as a prefix. So we will be calling it as NN-dimethyl methanamine. Okay. The next one is C2H5, N, C2H5, CH2, CH2, CH3, CH2, CH3. Okay, that's a correction here. So here it should be CH2 only, right? So again, you have to identify the longest carbon chain, which is going to be the parent chain, and we are going to treat all the other groups as substituents. So the longest carbon chain is the one which contains these 4 atoms. So N-butanamine is going to be the carbon, the parent chain, right? The common name of it is NN-dimethyl-butylamine. NN-diethyl-butylamine, and the IUPAC name is going to be NN-diethyl-butane-1-amine. As I told you, since there are more than 2 carbon atoms, therefore you will have to say whether it is at the first position or the second or the third position, depending upon the number of carbon atoms that are actually present. So NN-diethyl-butane-1-amine. Next is again a primary amine, but there is some unsaturation that is present in the compound, and therefore the name is going to go something like different, right? The common name of it is going to be allyl amine because this is the allyl group. If you remember, we had also discussed allyl alcohols. So there we discussed whatever we discussed remains the same here. So it's like the carbon atom to which nitrogen or oxygen, whatever, is the functional group going to be attached. When it is further attached to a carbon atom which is Sp2 hybridized and contains a double bonded carbon atom next to it, we call it as the allyl group. And had this carbon which is attached to nitrogen been directly bonded, double bonded to another carbon atom, it would have been a vinyl group. So here, this is allyl amine. So when I talk about the IUPAC name of it, it is going to be prop 2-ene 1-amine. Okay, now since we are starting with the functional group NH2, which is getting more preference as compared to the double bond, so we call it as prop because there are 3 carbon atoms. The second position has ene and the first position has amine. So that is going to be the IUPAC name of it. Next compound is this. This is pretty simple. It looks very complex, but this is easy to answer. Hexamethylene diamine. These CH2 groups are actually methylene groups, and since they are 6 in number, so hexamethylene, and since there are 2 NH2 groups, so diamine. Okay, so common name is, this is how the common name is going to be given for this particular compound. Now when we move on to the IUPAC name of it, what do we first see is the parent chain. Now here, this is going to be hexane 1,6-diamine. Simple. If there are 2 NH2 groups present, we are going to be putting the prefix di in front of amine and we will specify the positions. So it's going to be hexane 1,6-diamine. Now, let's move on to aromatic compounds. So this is going to have the common name aniline, or we can also call it as aniline or benzamine as the IUPAC names. Then we can also have a substituent CH3 attached to the ortho position. We call it as orthotoluidine, or the IUPAC name would be 2-aminotoluene. Then we can have para-bromoaniline or 4-bromobenzamine or 4-bromoaniline as the IUPAC name. Then we can also have NN diethyl group that is present. So it is going to be dimethyl group. So NN dimethyl aniline. And the IUPAC name will be NN dimethyl benzenamine. Okay. Now, the question for you is, you have to classify the following amines as primary, secondary, or tertiary. The first one is this. See, if you do not want to look at the, basically what you have to do is you do not have to get scared or, fear of having such a huge group. How are you going to predict? No, what you're simply supposed to do is you have to simply tell whether it is primary, secondary, or tertiary. You do not have to name it right now. Naming becomes difficult sometimes because it comes with a lot of practice, but primary, secondary, or tertiary amines can be easily predicted. You just have to look at how many hydrogen atoms from ammonia have been replaced. If 1 has been replaced, it is primary. If 2 have been replaced, it is secondary. If all the 3 have been replaced, it is tertiary. So here what do we see is when we take NH3 molecule, that is ammonia molecule, we see that one of the hydrogen atom has been replaced with some group, organic moiety. So this is the example of a primary amine. The second one is where all the 3 have been replaced. So it is tertiary. The third one is again primary because there is NH2. And the fourth one has NH, that is 1 hydrogen is left out of 2, that out of 3. So that means 2 have been replaced. So it is secondary. Okay, let's check our answers. Primary, correct. Tertiary, primary, and secondary. Okay, so I hope this is clear to you. Now you have to write down the structure of different isomeric amines corresponding to the molecular formula C4H11N. Now before I produce the solution in front of you, I would want you people to write down the isomers of this particular formula by yourself and then match the solution with your solution. And because this is a very simple question, it has nothing to do with the technicalities that are involved in the structures or nomenclature of amines. Okay, this is a very simple basic question, nothing to be very specific about. So let us have a look at the solution. Okay, and you have to also write down the IUPAC names of all the isomers. Now this becomes something technical. and also what type of isomerism is exhibited by different pairs of amines. So I hope you have studied the isomerism lecture before you have moved on to this particular lecture. If you haven't, just pause it here and go back to the isomerism chapter, the lecture of isomerism, understand the different types of structural isomers there, chain, linkage, etc. Then you will be able to answer this particular question. Okay, so what do we see here is that there are 8 isomers of C4H11N that are possible. What are these? The first one is where you have N-butyl amine, that is butane 1 amine, which is primary. Then you have another possibility of 2-methyl propane 1 amine, that is again primary. Another is the IUPAC name would be butane 2 amine, which is primary. Next one is primary again, that is 2-methyl propane 2 amine. Now this becomes secondary, that is N-methyl ethanamine. Another one is basically a secondary again, that is N-methyl propane 1 amine. Seventh is secondary again, that is N-methyl propane 2 amine. And the last one is tertiary, which is NN-dimethyl ethanamine. Okay, so I hope you've got these 8 isomers correctly drawn, named also along with the IUPAC names. Now, this was the answer to the first and the second part. Now, the third part was that which type of isomerism is exhibited by different pairs. So we have chain isomers exhibited by A and B. So go back to the structures, draw the structures, and then you can compare if you've correctly given the names of the isomers. So AB, AD, BC, and CD are chain isomers, that is differing in the length of the chain. Positional isomers A and C, B and D, F and G, that is differing in the position of the functional group NH2. Then functional group isomers A, E, AF, AG, AH, BE, BF, BG, BH, CE, CF, CG, CH, DE, DF, DG, DH, EH, FH, and GH. All these are functional group isomers. And the definitions of all of these isomers will be given to you have already been given to you in the isomerism lecture. So I would suggest you that if you've not understood this, I'll not be explaining all the types of isomers again and again, how we have derived all of this. You will be able to understand how we have derived this if you are very clear with the isomerism lecture already. So go back, revise the isomerism lecture, and all this will be definitely clear to you. Okay, because if I repeat it again, there is no point. You can go back to that lecture, understand, and then answer this question if you've not really been able to grasp every part of it. Then there are metamers also, ENF, ENG. Let us have a look at an MCQ towards the end of this lecture. The structural formula of N-methyl aminomethane is. The options have been given to you. Now, if you carefully see N-methyl means there is one methyl group that is attached to the nitrogen atom. Then aminomethane means there is an amino group and there is another methane, means 2 methyl groups attached to the nitrogen atom. So obviously one is going to be hydrogen. Let us see which structure satisfies the definition that we have understood. That is option C is the right answer. IUPAC name of this particular compound, you have to tell that what is the IUPAC name of it. Now, if you carefully see, then what you have is CH3, CH2, NH2. So this is pretty simple to predict. This is 1-propanamine. That is option A is the right answer. Which of the following is a primary amine? Very simple. You just have to, what do you have to do? Look at the number of hydrogen atoms that have been replaced. So wherever there is just one hydrogen atom replaced and 2 are present, that is going to be primary amine. And we look at the options and find that option A is the right answer for the asked question. Lastly, which of the following is a secondary amine? Again, look at the number of hydrogen atoms. Wherever there is one hydrogen atom present and 2 have been replaced. So whatever has been replaced is going to be the type of amine. So 2 replaced means 2 degrees. So it is secondary, and that is satisfied by option D. Therefore, it's the right answer. So this is all about the structure, classification, and nomenclature of amines. I would suggest you to practice a lot of questions based on the nomenclature part, and also be well aware of the common names of whatever compounds that you're going to practice for IUPAC nomenclature. Because it's only with practice that you will be able to master all these topics in organic. Okay. You can subscribe to our YouTube channel for joining YouTube live classes for best NEET or JEE coaching. You can also download the First Online University mobile app through Google Play Store or App Store for continuous learning through your smartphones. Keep learning with First Online University, a team of millions of learners and educators worldwide.